everybody. My name is Richard Conley, and this is my group's presentation on drip irrigation. My fellow collaborators in this project are Era Barjona, Maria Granados, and Zoe Cardenas. What is drip irrigation? Drip irrigation can be seen as an answer to the irrigation question of how much water. While flood irrigation, in sharp contrast, can be seen as adding enough water, drip irrigation is aiming to add as precisely as much water as you need. Drip irrigation has been developed for the while at this point. The earliest rendition of drip was in the 1860s when experimentation was done with porous clay pipes, but drip as we know it today was invented in the late 1950s in Israel. Plastic lines with emitters and all that. Developed by the gentleman on this slide, Simcha Blas. I believe that's how his name is pronounced. If we get into another definition, drip can also be defined with how water flows through the system, continuously through lateral lines, through emitters connected to said lateral lines, and openings on these lateral lines. Now, the components of drip are variable, but there is a couple of necessary, always present features. The first one would be, of course, a water source. You can't have irrigation without water, but that is a universal feature of all water systems. What isn't is having a pump. Flood irrigation, for example, doesn't really use pumps, but some other ones do. This pump pumps the water through a filter and a main line. Filtering systems, while technically not absolutely necessary for drip, are a practical necessity. Sand media is typically used, and this clears out any debris that could possibly hopefully clears out any debris that could possibly get stuck in any of the emitters. Fertigation is also a technically optional system, but it is very useful for simplifying fertilizer applications. Of course, a control system to control the flow of water in your system, and the distribution through lateral lines, which lead to emitting devices. Now, one thing I have noted on this page is the graphic I used. I got this from a drip trickle or micro irrigation. The editor was someone with a PhD, but the image shows the chemigation going before the filters. I believe you wouldn't want to do this because most filters would remove whatever you add via chemigation, which is just generally, I think, an error, but it's still a very good graphic when it comes to showing the main components of a drip irrigation system. So when and where to use drip irrigation? Now, drip irrigation is a very robust irrigation system. It's been noted to increase yields where applied and decrease water use where applied. It doesn't come with its own handful of issues, mind you. The upfront costs of drip are much higher than, say, just flooding your field. There's also the cost of maintenance. If your emitters get clogged, that is a massive insertion of manual labor. And of course, there is the cost of replacing your drip lines, with many drip lines not being designed to last more than a season. With the bullet points on this slide, you can see the general points where you might want to consider drip. If you have a very valuable crop, it might be worth doing drip to get the extra little bit of value out of it. If water is not cheap where you are, it might be worth doing drip. And of course, in certain areas, you are legally required to do drip to save water and minimize overspray. Of course, you might also want to consider some other factors such as your soil conditions and the crop you're growing to begin with. Some crops aren't even known to benefit from drip, and some soils are known to be quite difficult to do with drip. Sandy soils, for instance, have been known to not properly diffuse water, which makes using drip irrigation a lot harder.
Designing the layout. As Richard had mentioned, soil type is the first thing we must determine in order to know how much water we would need and how long to run the system for. Residential and commercial needs can vary quite differently, so whichever you may need can also determine which emitters and setup you would prefer to use. In a commercial setting, you can have a basic layout like this where you have a filter and a pressure regulator feeding the main line, and the main line is going down to each row with an emitter on each plant, which can be seen at the Spadra farm, which has this layout, and they have micro sprinklers, but you can also have drip tape, soaker hose, drip emitters, and bubblers, whatever you need in order to feed your plants in the best ways possible. So if we take a look at the image on the right, you'll again see a commercial setting where you have a filter connected to a pressure regulator that feeds the main line. You have drip tape connected directly to it and end caps and fittings at each row. This is similar again to Spadra, and they do subsurface drip for their strawberries, I believe. This leads us to drip for residential settings. I have a quote here by Hunter Industries Drip Guide. It says, drip irrigation is an ideal solution for irregular or small areas. The beauty of drip really shows when in a residential setting. Here you have all the options available and can customize your design for your needs. Say you want to add drip to a garden bed and a few shrubs, like the scenario here, in a small location where sprinklers would not make an idea. Pretend that this is also a smaller area. Say we had fencing here. If we had sprinklers, there would be overspray caused all around, and say there was an irregular shaping for this patio or backyard. This is where drip would be very adaptable to the twists and turns to it. This also allows us to be able to irrigate our plants while still being able to use our patio or backyard. Say there is a grill or some sort, you wouldn't want to be grilling while the sprinklers are going off. But with drip, you're able to do that and even run them at peak heat times to prevent heat stress. With drip, it also gives us the option to mix and match. Say we were doing sprinklers along the fence and we still wanted a raised bed. In order to do that, we can have a specialized adapter that goes from sprinkler head. You take the internal workings of it and you switch it over, and it has a valve that also has the pressure regulator and filter built into it so that you can feed it downwards and connect it to drip tape or emitters and have her set up in your garden that way. Sizing the system. Here we have two images of two different nurseries. On the left you have Cal Poly and the farm store. This was taken after they had cleared out their nectarines and peaches, but as you can see there's a PVC piping that connects to the main line, and it feeds to the spaghetti tubes and down to the emitters. Over here on the right is a greenhouse that was getting ready to get in season for poinsettias, and again you see the main line feeding down with individual spaghetti tubes and emitters at the ends. And this image below was taken from the Huntington Library and one of their greenhouses. This little device was custom built. You can even see all the little workings of it, and this allowed them to do individual feeds for their wide variety of plants and plant species. And if you've ever been there, you will know how much care goes into each one. So this is what they had to come up with in order to properly feed everything without um, any nutrient toxicities or without inconsistent feeding. So then all these, you'll see tubes and so on, but each one of these will have their own spaghetti tubing with emitters in each plant. So they'll go down each bench in order to feed it and replenish the feed as much as they need. Um, so sizing the system is very capable. I've seen this also in larger scale for agriculture. I've seen it in Piru, California for the Verde company. They were growing grafted avocados for big box retail stores for Home Depot, Lowe's, and whatnot. Costco actually ended up buying one. Hopefully, I seen it when I was out there. But yes, they feed their avocados through drip emitters, and they even collect the runoff to be able to recycle that water and reclaim water, clean it and process it, of course. But they like to do that because the water will have high salts. So if they process their own water, they're better off and they can manage their own salt levels better than if they would um, by relying on municipal waters. So again, drip can help with multiple situations. It's really easy to size up or down depending on your needs, and also different variations of it can be used in the same situation. Normally in commercial settings, you would not see too many variations unless, again, for different plants, there's customization. Um, they won't probably be doing this for other sections. Um, they had sprayers in other greenhouses. This one was on the in the tour I took, so um, this was just a special device I really found interesting. But this allowed them to use drip evenly and distribute evenly for all their plants' needs.
To set up the mainline, you first have to look at tubing that'll suit your project considering PSI regulations and the size that you will need. After you choose a perfectly sized tube for the mainline, you could then lay out the tubing that you need for your setup. You can cut the tubing at the desired length with scissors or garden shears. Then you can place the tubing at desired areas within the space you are installing your drip irrigation. After, you will need an elbow or T-fitting to connect more mainline tubing or micro tubing. To set up the mainline, to install drip tubing, you have to determine the placement of the tubing depending on the distance between each plant and how many emitters you are going to use. To install the tubing, you start by punching holes in the main line that is appropriate sized of the tubing used. You then attach a connector to the puncture that you just made by inserting a feeder into the end of the main line. Take a section of the tubing you are using to attach it to the main line, then attach it to the connector. Once you have measured out the length you need, you could then cut the tubing. Emitters for drip irrigation can vary depending on the type of plants or crops you are watering. The most common types of emitters used are online and inline drippers. To set these up, you first must look at which emitter type, size, and color best suits your project. Emitters need to be placed around a meter apart along the drip line. 1 to 2 emitters are needed per plant and should be placed depending on the flow rate and water requirement for certain plants. They can then be placed on the end of each line of tubing that is attached to the main line. To install drip tube, testing your drip irrigation system is crucial for it to last in the long run. Start off by turning on your water source or starting the pump and make sure the water is at the correct pressure. You should check the pressure at the furthest and closest points on your tubing from the main line. All pressure readings should be around the same pressure. Testing the flow rate of each emitter should also be like testing the pressure. You should have similar readings. If your system varies too much, you may have to go back and investigate your system for any problems. Testing
regular maintenance task for drip irrigation. You need to keep your drip irrigation systems in excellent condition. It's important to perform regular maintenance tasks, and here are some practices you should incorporate into your maintenance routine. So, number one, checking for leaks and clogs. Inspect your system for leaks, especially at connection points and around emitters. Leaks can result in wasted water and reduce system efficiency. Fix any water drips or leaks right away to stop more harm from happening. Also, check for clogged emitters and clean them if necessary. Clogged emitters can disrupt water disruption and harm your plants. Number two, inspecting and cleaning filters. Regularly inspect and clean the filters in your micro irrigation system. Filters prevent debris from entering the system and clogging the emitters. Clogged filters can lead to reduced water flow, uneven distribution, and even damage to the emitters. Clean the filters according to the manufacturer's instructions, ensuring they are free from blockage or buildup. And third, adjusting water flow and pressure. Periodically, check the water flow and pressure in your system. Adjust the flow rate and pressure according to the specific needs of your plants. High pressure can damage emitters, while low pressure may result in inadequate water supply. Ensure that the water flow and pressure are optimized for efficient operation. Seasonal adjustments in drip irrigation. In addition to regular maintenance, seasonal maintenance is crucial to adapt your drip irrigation system to changing weather conditions and preserve its longevity. Before winter arrives, it is important to prepare your drip irrigation maintenance system for the cold weather. Start by draining all the water from the system to prevent freezing and potential damage. Remove any excess moisture from the lines and store them in a dry place to prevent cracking or breakage. As spring approaches, it is time to assess the condition of your drip irrigation maintenance system. Look for any problems or broken things that might have happened during the cold winter. Inspect the emitters, tubing, and connections for wear and tear. Replace any damaged components and perform a thorough cleaning before resuming regular operation. Now, during the hot summer months, it is essential to adjust your drip irrigation system to meet the increased water demands of your plants. Regularly monitor the water supply and make adjustments to ensure your plants receive adequate hydration. Consider adding additional emitters or extending the irrigation time if needed. In the fall, prepare your drip irrigation system for the upcoming winter. Clear any debris that may have accumulated throughout the growing season. Inspect the entire system for leaks, clogs, or damaged components. Address any issues promptly to prevent them from worsening during the winter months. Troubleshooting common issues in drip irrigation. Despite regular maintenance, you may encounter some common issues with your trickle drip irrigation maintenance system. Here are a few troubleshooting tips to help you identify and resolve these problems. Managing pressure problems. Inconsistent water pressure can cause emitters to malfunction or produce uneven water distribution. Ensure that your pressure regulator is functioning correctly and adjust it as needed. Consider installing a pressure gauge to monitor and maintain optimal pressure levels throughout your system. Dealing with clogged emitters. Clogged emitters can disrupt water distribution and negatively impact plant health. To unclog an emitter, remove it from the tubing and soak it in warm, soapy water. Gently clean the emitters with a small brush or use a pen to clear any debris. Rinse thoroughly and reattach the emitter to the system. Identifying and fixing leaks. If you notice water pooling or damp spots around the system, it may indicate a leak. Inspect the entire system and look for damage or loose connections, cracked tubing, or faulty emitters.